So here are the formulas that we will be using for testing in single population variance case, and we can have the three possible formats for the hypothesis. One tail, the left side tail, where the alternative hypothesis is less than a given value for standard deviation or variance. You can set it up in either format. Either you can use standard deviations to set up the hypothesis, or it could be variance, or it could be one tail on the right side or the two tail test. And the test statistic that we will use is this, and we can conduct the test using the chi-square table value, in which case the chi-square table value for the first left side tail test would be the left side chi-squared table value. So we will use chi-squared.inv. So chi-squared table value for the left side table value, we'll use chi-squared.inv, and alpha, because it is one tail, we shouldn't divide by 2 degrees of freedom. For the right side, we have another function called chi-squared.inv.rt, and once again alpha, degrees of freedom. In case of two tail test, you need to have two different chi-squared values. So we have chi-squared alpha over chi-squared chi-sq.inv. Just alpha over 2 will give you the left side table value, and the .rt function, again you use alpha over 2 because there are two tails, will give you the right side tail. And the p-value functions are similarly, you use chi-squared.dist function. Okay. Now we need to include that comma 1 to indicate that we want the probability. So if it is a left side tail, one tail test, then you use chi-sq.dist, and if it is a right side chi-squared test, you use chi-squared chi-sq.dist.rt. When you use rt function, Excel automatically knows that it is the probability that you want, so you don't need the comma 1. Only chi-squared.dist function uses comma 1, not the rt function. Now for a two-tail test, okay, here is where you have to calculate the p-value in a slightly roundabout way, because chi-squared can be either on the right hand side or on the left hand side. And so we cannot use absolute value like in normal distribution, because normal distribution you can have negative or positive, but here everything is positive. Chi-squared is only positive, so you cannot be sure which side which side of the tail the chi-squared calculated value falls. So you have to look at the left side tail like that, okay, using the left side formula, and you have to look at the right side tail like this, and then select the smaller of these two, and that would be the value of one tail, and you have to then multiply by 2 because it is a two-tail test p-value.